Algebra II 7.5D, Rational Exponents to Simplify Radicals. We now have 15 previous videos for this chapter. If you haven't seen them, you might want to click on the description so you can watch them real quick, or if you become lost, you can backtrack and find out what you're missing. Rational exponents can be used to simplify some radical expressions. And to do this, number one, we convert the radical expression to an exponential expression. We did that in 7.5b and c, the two videos before this. So we've got the sixth root of 4, and we can rewrite it in exponential form as 4 to the 1/6 power. That little sixth root is the denominator of our exponential little number up here. See that? That's the denominator. And the 1 numerator is the 4 to the first power. See? Second thing we do is we use the properties of exponents to simplify them. And there's a link to video 1.8D in this description in case you've forgotten all your properties of exponents and your rules. This 4 to the 1/6 power can be rewritten as 2 squared to the 1/6 power. And we raise the power to the power. And now the power rule tells us that we can multiply these two, and we get 2/6 as our exponent, which can be simplified to a 1/3. The last thing we do, the third thing, is we convert it back to a radical notation when it's appropriate. So now we've got this 2 to the 1/3 power. This 3 is our root, our index, and our 2 is under the radical sign. So we got the cube root of 2. That denominator is the index. It's the root. So using rational exponents to simplify, we've got the sixth root of x cubed. We can rewrite this as the 3 as our numerator and our 6 as our denominator of our exponent. It can be simplified to x to the 1/2 power. And because that 2 is our root, our index, we get the square root of x. See, there's a little 2 there, and the x is to the first power. All right? That denominator is the index. It's the root. If we've got the fourth root of 25 squared, we can rewrite this as 25 to the 2/4 power. Here's our numerator. Here's our denominator. We can simplify that to 25 to the raised to the 1/2 power. And what that means is if this is our root, our index, that little 2, we have a square root of 25. And the 25 is to the first power because that's our numerator. And the square root of 25 is 5. That index is the denominator, and the denominator is the index. Let's look at this one. We've got the 8th root of a squared b to the 4th. We can rewrite this with the a squared b 4th inside of parentheses and raise it to the 1/8 power. And we can multiply a as a 2 times 1 over a 1 times 8 when we multiply it to this 1/8 exponent. And the b can be 4 times 1 over 1 times 8. That's going to give us a to the 2/8, b to the 4/8. We can simplify this, and we want them to have the same denominator. So this isn't going to simplify to a 1/2. We want them to have the same denominator, so it's going to be 1/4 and 2/4. And then using the property of exponents, that 4 can be pulled out as our 1/4 exponent outside of here, and we just have an ab squared. See? There's one of them here, there's 2 of them here, there's 1 here, there's 2 here. See, that's the numerator? And it's to the 1/4 out here, so we raise the power to the power. That's the third power rule for exponents, says that we can do that outside the parentheses. Now we convert it back to radical notation, and this is our root. So we've got 4, the 4th root of ab squared. See? Just keep remembering that that denominator of that rational exponent is the root. That's all. It's the index. And we can use properties of rational exponents to write a single radical expression for a product or a quotient. So if we've got the cube root of 5 times the square root of 2, we can convert them to exponential notation. So we've got 5 to the 1/3 power times 2 to the 1/2 power. That's our little denominator, and because that's a square, there's a 2 there that's invisible, isn't it? We find a common denominator for the 3 and the 2, and that would be a 6. And we get 5 to the 2/6 times 2 to the 3/6. The second power rule for exponents says we can write it like this. We've got 5 to the second power, or 5 squared times 2 cubed. There's our root, the 6. We can rewrite it back to radical notation. And when we do 5 times 5 and 2 times 2 times 2, we get 25 times 8, which is a 200. So when we simplify it, we've got the 6th root of 200. See? See how I did that? Let's try this one. Now we've got the square root of x minus 2 times the 4th root of 3y. We can convert it to exponents. So we know there's a little 2 that's hidden here. So we've got x minus 2 raised to the half power. See? There's a little 2. That was our index. This is to the first power. So that's why our numerator up here is a 1. And this is our denominator, isn't it? And this is to the first power. So we've got 3y to the 1/4 power. We can write it with common denominators because that's a 2 and that's a 4. We can give it both a 4. So we've got 2/4 and 1/4. And the second power rule for exponents says we can write it like this. We've got x minus 2 squared times 3y and they're raised to the 1/4 power. This is the numerator. See, and that's got a numerator of 1, so that's why there's a 1/4 there. We can FOIL this, x minus 2, x minus 2. And we're going to get x squared minus 2x plus 4 times 3y, and it can be simplified to minus 4x when we combine the like terms. We can distribute this 3y, and we get the 4th root of 3x squared y minus 12xy plus 12y. See? All right, we got a couple more. Now we've got the 4th root of, we've got the quotient of the 4th root of x plus y cubed and the square root of x plus y. We convert to exponents, and we get x plus y raised to the 3/4 power and x plus y to the 1/2 power. The quotient rule for exponents tells us to subtract these, and we need to find a common denominator, don't we? So we can use a 4. So we get 3/4 and 2/4. So that's going to leave us 1/4. We convert it back to a radical. That is our root, and we've got the 4th root of x plus y. See? Let's try the last one. We're going to write a single radical expression. We have a raised to the half power, b to the negative half, and c to the 5/6. We can give them all common denominators, so they can all meet at 6, can't they? So we get 3/6 and negative 3/6 and 5/6, and we can write them in parentheses like this and say, because here's our numerators, so those are going to be our powers inside the parentheses, and that 6 is going to be out here as a 1/6. So we get a to the 3rd, b to the negative 3, and c to the 5th. We can convert it back to a radical expression, and here's our root. So we've got the 6th root of a to the 3rd, b to the negative 3rd, c to the 5th. Okay? So we were able to simplify all of these. Now our next video is going to be 7.6. So we're done with the 7.5. So we're going to do 7.6a, and we're going to do radical equations and the principle of powers. I'm going to add this video to the Algebra 2 playlist. All the links to Algebra 1 from last year, where we talked about a lot of this, will be in this description. And that 1.8D rules for exponents is going to be in this description. And the previous 15 videos. So it's going to get really long in that description, but I'm doing it to help you so that in case you've missed any, you could just click on this description, not have to look everywhere all over YouTube for these, and you'll see them all in order, all nice, ready for you to just click on and watch. Okay? You watch every single video, and you should get good grades in math because you'll have it all, and you can watch them over and over again as many times as you want. Don't forget, I have YouTube fan funding on my homepage, and you can go to patreon.com to help me out and help Lola and Bitsy out, and even if it's just $1 or $2 a month, I'd really appreciate it. If I'm helping you, I'd really appreciate the help back in return and your generosity, okay? I'll see you next video. Keep trying. Bye.